Today we are going to learn about slope-intercept form of an equation. Yesterday we said that we're starting to talk about linear equations. So linear has the word line in it. Linear equations graph as a line. So we need to look at what their equation would look like. Now one way we're going to see the equation is in what's called slope-intercept form. And you may have heard of this in middle school. Y equals mx plus b. So let's talk about what all these pieces mean. Now you already know about x and y because we've talked about it. We said that y, think about our acronym, ROY-D. Y is the range, the output, and the dependent variable. We should know this by now. We have talked about this a lot. So that's y. Then x, we know this from our friend Dixie. X is the domain, the input, and the independent variable. So the things that are new to us are the m and the b. M, I alluded to it yesterday when we talked about slope. I told you that sometimes slope can be represented with an M. I don't know why, because the word slope does not have an M in it, but M is the slope. Remember that I said slope is rate of change. When I say rate of change, you need to know that I'm talking about slope. It's also rise over run, which is helpful when we're graphing, where we're looking at a graph of a line and wanting slope on the graph. All right, so the brand new thing is B. B is your y-intercept. In case you're unfamiliar with that term, y-intercept is where the line that we're going to graph, the linear function, the line, where it crosses the y-axis. So we're going to write that down, where the line crosses the y-axis. It's always your starting point. B is always your starting point. So if we're even in a situation, a word problem, some kind of application, your starting point, wherever that starts, is always the y-intercept. So let's talk about, so first of all, here's the y equals mx plus b. Here's your slope-intercept form. Let's talk about if we saw an equation like this in slope-intercept form and we wanted to graph it. We wanted to graph the line and see what it looks like. So I've got some steps that we would follow in graphing our line. So graphing linear equations. Remember that we know that linear always graphs as a line, a linear function, one that graphs as a line. And it has the word line in it, so that is a hint to us. So let's talk about some steps we would follow when we were graphing linear equations. So the first thing is to make sure your equation is in slope-intercept form. We can't graph it if it's not in slope-intercept form. Now tomorrow we're going to talk about what to do if it's not in slope-intercept form. But today the only ones we're going to look at are already going to be in slope-intercept form, which is y equals mx plus b. Now I told you that b was your starting point. So the second thing you're going to do after you make sure it's in slope-intercept form is you're going to graph b. That's your y-intercept. You're going to put your y-intercept on the graph. I'm going to show you how to do this here in a minute. Then we're going to use your m. What's m? M is slope. We're going to use the m, the slope, and we're going to count rise over run to find our second point. Remember yesterday we had 2 points and we counted and found the slope. So today we're going to have 1 point, your y-intercept, then we're going to count our rise over run from that to find our second point. Now, always count from B. Some people, I notice, will try to count from the x-axis. We don't count from the x-axis. When we start counting our slope, we count from B. The other thing I want you to do is look at your slope and see, is it positive or negative? Then think about the slope dude video we watched and think about which way your line needs to look. If you graph that line and you had a positive slope and it looks negative, you've done something wrong. Go back and try again. So then the last thing you do is you connect your 2 points. Remember yesterday I said that it only takes 2 points to make a line. Connect your 2 points, draw the line, and then add the arrows. Don't just stop at your 2 points, because then you haven't graphed a line. A line goes forever and ever and ever in both directions unless I give you boundaries, and we're not giving you boundaries on these. So the line goes forever and ever in both directions. So make sure that you add the arrows to demonstrate that. Whoops. And therefore, what would your domain and range be? If a line has arrows going forever in both directions, your domain and range would be all real numbers. So let's look at how to graph some of these. Let's follow our steps here. Make sure our equation is in slope-intercept form. Is this one y equals mx plus b? Yes, it is. So what is m? M's always attached to the x. M is 2. What is b? B's always added last. There's b. So what do I do next? My notes that I just took say graph b, your y-intercept. So here's b. It goes on the y-axis, count up to 4. There's my y-intercept. And then I count my rise over run from b. Well, what do I do when I have a whole number? My slope is 2. I need it as a fraction. How do you write a whole number as a fraction? Well, you put it over 1. So my rise is 2, my run is 1. Count from this point, 1, 2, 1. I went up 2 over 1. If you want to get a better, more accurate graph, you can keep going up 2 over 1. Oh, could I go down 2 and left 1 to go this direction? Yes, I could. Now let's connect our dots, add our arrows, and we have graphed a line. So this equation represents every point on this line. Let's look at another one. We have, it is in slope-intercept form. What is slope? It's attached to x. It's negative 3 over 2. And what is my y-intercept? That minus there goes with it. Make sure you do that and you put that the y-intercept is negative 3. So I go down to negative 3 on the y-axis and I put a dot. Now I'm going to count a negative slope. Negative means that I have one negative move. I either go down or I go left. So here, if I'm going up and down first, I could go down 3, 1, 2, 3, and to the right 2. Look at that. Would that be a nice negative? Would that be a negative slope? Yes, it would. So I've gone the right way. I also could have gone up 3 and to the left 2. The left could have been my negative move. Connect your dots, draw your arrows, look at your line. Is it a nice negative? Yes, it is. Let's look at the next example. I don't know why these examples started with number 5, but that's fine. Y equals mx plus b. What happened to the plus b? There's nothing there. Couldn't it be plus 0, but there's no reason to write the 0? So I'm going to say that my b is 0 because there's not one. What's my slope? Negative 4. I need it as rise over run. So let's put negative 4 over 1. Start at your y-intercept, which is actually the origin. This time it's 0. And then count down 4, 1, 2, 3, 4 to the right 1, or up 4, and to the left 1. Is it a nice negative? Yes, it is. Now let's go to the last one. My slope, it is in slope-intercept form. My slope's attached to the x, so my slope is 5/3. Don't forget that that minus actually attaches itself to the 4, making it negative. Go down 1, 2, 3, 4, negative 4. Then from this, count rise over run. Rise 1, 2, 3, 4, 5, run 3. There's your second point. I could do it again. Rise 5, run 3. Is this a puff puff positive? Yes, it is. So this is how to graph equations, graph lines when the equation is already in the slope-intercept form.